Oh man, this is such a waste.
I know. Did you know that the average person uses 30 to 50 batteries in a year?
No way.
Yeah, and did you also know that in the United States, 2.9 billion batteries are thrown away each year?
That's so much.
Yeah, this equates to 150,000 tons of batteries in our landfills each year. Alkaline or single-use batteries,
Like this?
contain hazardous metals like mercury, steel, zinc, and manganese.
Wow.
They also contain potassium hydroxide and electrolytes.
Those sound dangerous.
Rechargeable batteries are even worse.
No way.
They contain mercury, cadmium, lead, and lithium. Car batteries contain lead and acid.
No way. Acid?
It's clear that environmental impact associated with manufacturing and disposing of batteries is huge.
No, it seems like it.
Batteries are manufactured using metals and natural resources and require a lot of energy to make.
Really?
Yeah, ultimately, these batteries end up in landfills and pollute groundwater. This is the water which we drink.
Oh my god.
There has to be a better alternative. What if there was a battery that was better for the environment and more efficient? Scientists are working on developing new types of rechargeable batteries known as supercapacitors. Supercapacitors are made from various porous carbon materials. Recent supercapacitors have contained activated carbon made from coconut shells. In 2010, the Nobel Prize was awarded to the inventors of graphene, a substance composed of pure carbon. Graphene is used in supercapacitors. Graphene is very light with a 1 square meter sheet weighing only 0.77 milligrams, and it's only 1 atom thick. The charging current separates the ions from the electrolyte and are attracted to their opposite electrodes. This membrane serves to separate the ions so that the net charge separation can be maintained. Notice that the ions on the electrode surface are neutralized by the opposite charge attracted to just below the surface of the electrode. This double surface layer is called an electric double layer and helps supercapacitors store more energy.
The capacitor is able to charge quickly but also discharge quickly. The supercapacitor offers the best of both worlds. It charges quickly and discharges slowly, allowing for longer power life. The supercapacitors contain porous carbon atoms that can hold more electricity longer than non-porous materials. Like a sponge in water, a graphene supercapacitor soaks up electricity quickly and holds it in longer. Once developed, a supercapacitor cell phone could charge in 10 seconds rather than hours. Another advantage with the supercapacitor is that they are bendable and twistable. They could potentially be useful in flexible electronics like a roll-up TV or a laptop that you could fold and put in your pocket. Also, since they are made of carbon, supercapacitors are biodegradable and can be disposed without hurting the environment.
There is still much to be learned. Richard Kainer, a chemistry professor at UCLA, is a leader in research into potential uses for graphene supercapacitors. So far, the uses are limited to smaller electronic devices like pacemakers and cell phones, because the energy output is relatively small. If advances are made with technology, these batteries could power larger machines in the future, like wind turbines and cars. If this could work, we could recharge our car in the same amount of time it would take to fill a gas tank. Other disadvantages are that it has low voltage, and as it discharges, the voltage also goes down. So your computer or cell phone wouldn't work as efficiently on 20% battery than it would on 100% battery. It also relies on graphite, most of which is mined in China and India. So we would have to depend on them to import the material to make graphene batteries.